All right, so the first thing I'd like to recommend people do before they attack problems is be aware of some of the formulas that are available, and you will need to know rather quickly as you take this test. First thing I want to say is it's going to be very important for you to try to commit these to memory, and I'll give you pointers on what you can do to memorize these formulas. But the test won't allot you time to wonder, okay, what formula was that? Okay, now how am I going? Is it pi r squared? Is it 2 pi r? The test won't give you that kind of time. So it's important for us to start where I'm starting, to try to give you some strategies as to how to commit these formulas to memory. So let's do that. It's not too many of them. We'll try to do the best we can. All right, so base times height, that's a common one. You'd have to know that. You'd have to know that the area, which is the space inside, let's write that down, space inside of an object, for rectangles, base times height. I'd like you to be able to notice that a triangle, if you cut a rectangle straight through the diagonal, you end up with a triangle, which the formula for the area of a triangle is half of what a rectangle is. So though you have to memorize two different equations, I want you to be able to see that if you memorize a rectangle, the triangle is not too far from that. So it's easy to commit to memory both. I'm also showing you that's two types of, really more than that, but here are two types of triangles that you'll be presented with. And I'm trying to show you that the height is always perpendicular to the base. Height forms that L shape with the base. This we call a hypotenuse. We'll talk about that later. Space inside of a circle, given by the formula pi r squared. Notice how half of a circle, formula for a semicircle, half circle, is half of the whole. That makes sense. So really you're only committing a little bit to memory. Just really basically two equations to memory. All right, because the others come from the initial. The perimeter, which is distance around an object. This is distance inside of an object. This is distance around an object. Formula for distance around an object is, let's call this the base, let's call it the height. Let's call that the base, let's call that the height. Two bases plus two heights. Base plus base plus height. Two bases plus two heights. I'd like that to make sense. If it makes sense, you don't have to memorize it. Here, the perimeter, or the distance around the triangle, is the lowercase height, which is the height of the shape. Uppercase height, or excuse me, I didn't mean to say height, hypotenuse plus the base, distance around. And then one way you can get that uppercase height is called the Pythagorean theorem. We'll talk about that later as well. But one way you can get this height, you can get one leg of a triangle given two, using this Pythagorean theorem. The circumference or perimeter of a circle, that's 2 pi r. The perimeter of a circle, distance around a circle, is 2 pi times r. We define r as the distance from the center to the edge of the circle. There are an infinite number of radiuses of the circle from the center to the edge of the circle. From the center to the edge of the circle, we call those radiuses. The distance around a whole circle is 2 pi times whatever the radius is. Then, last thing I really want to talk about right now is the volume. Notice I have the volume, same equation all the way through. I'll try to make that as easy as possible for you. We're going to do the same formula all the way through. Capital B means the area of the base. Area of the base. So I probably spent too much time talking about those formulas, but they are very important. They are very important. They're the backbone of solving all of these geometry problems that we're going to go through tonight. All right. So this is number 4, page 919. Number 4, let's take a look. Number 4, it says the diagonal of a rectangle is 17. So you draw a rectangle. Let's make it so you can see what we're working with here. All right, sorry about that. Number 4, the diagonal of a rectangle. So you draw a rectangle. The diagonal of a rectangle is 17. All right, its length is 15. What is the width? That's the width. What is the width? All right, so you got to be able to see that that is a triangle. That is a triangle. You've got two sides. You got two sides of a triangle, and you need the third side. Well, you'd immediately go to what we talked about. Here, we told you right here, Pythagorean theorem. If you have two sides, you need the third side. You can always use the Pythagorean theorem if it's a right triangle. So, one of the things we did not say is that this hypotenuse always has to be inserted into the C, all right, or in this case the H, what I had written down. So you have 17 squared, 15 squared, plus W squared, and boy, I don't have my calculator here. Let's see what we're going to do. Maybe I do. Let's check to see if we got the calculator. Well, I tell you what, let's just do it by hand. We got 17, 9, 49, you get 111, 7, 1, you get 9, 289. All right, you get 289. And here you get, I believe this is 215, 15 square. Oh, that's 225, I believe. 225 plus W squared. That's W squared. I believe that's correct. And then you get 289, and you get 225. You get 64. So you subtract that over. You get 64 is W squared. You take the square root of both sides. You get W is 8. And that would be the answer you'd go for, which would be number 2. It'd be 8. The width would be 8 inches. All right. So let's keep going. Try to get through as many problems as we can. All right. So let's look at the last one on this page. What they're looking at, it says number 5. Number 5. Let's take a look at number 5. Number 5 reads, a local radio station broadcasts a 21-mile radius. How many square miles does it cover? Square miles. That's as you study, you'll discover that, and as opposed to cubic represents volume, cubic inches, cubic yards, cubic feet, that's a unit of volume. Square miles, square inches, square feet, that is a measure of area. See, you'll have to read problems and know quickly which formulas to go to. It's very important that you be able to look at keywords, or in this case, look at units, and know right away, hey, square miles, that is an area that requires a formula for area. The area of what? Good question. An area of what? Is it an area of a rectangle? Is it an area of a circle, or what? It said, look at the key here. A local radio station broadcasts over a 21-mile radius. Radius. The only shape that requires a radius is a circle. So you'd know right away to go to the formula for the area of a circle. So you got to be able to study so that you know immediately how to attack these problems. All right, so you got area, pi r squared. You will have committed that to memory. All right, so they tell you that the broadcast over a 21-mile radius. So you get pi, you put in 21 miles, you square it, and you're going to get the area, no problem. I did that already, and I got 1,386. I want you to call in 312-738-1060 if you have any questions on a problem that you would like to go through. I've got plenty of problems that I want to work on. But if you call in, that's how the show works best. All right, let's keep going. This is a problem where it says Ramon needs to carpet a room. That tells you right there, he's trying to carpet the room. When you're trying to carpet a room, you want to put the carpet on all the inside of that shape. That tells you what you're working on. So when you read these problems, ask yourself, hey, is this a perimeter problem? It's an area problem, and you'll be fine. All right, so your carpeting room, it costs $16.99. Don't use $16.99. Round it up to 17. Make your numbers easy to work with. Easy to work with. So $17 per square yard. I told you earlier, square yard, that is the unit for area. That's area. So not only the problem, you carpeting the floor, the inside, that sort of directs you, you're working with area. The units itself is a giveaway, working with area. Disregard the waste. How much will it cost to carpet the room? How much will it cost to carpet the room? Well, notice how they don't give you the radius. You need, that's an area. That's the area of a rectangle. The base, you need a height. You don't have the height. You also need a radius. You don't have the radius. So for this particular problem, they did not give you enough information. They did not give you enough information. Had they given you this radius, let's say it's 4, let's say they would have given you this distance of 4, you would have been able to not only find the area of this half circle, half pi r squared, but you would have also had the height of this rectangle. This from here to here would have been 4, and from here to here would have been 4. The height of the rectangle would have been 8. So if they would have just given you this one distance here, you would have been able to find the area, no problem. No problem. All right, so they didn't give you enough information. Let's keep going. Try to get through as many problems as we can. Let's look at number 7. Liz planted a triangular flower bed with the dimensions shown below. What is the area? Here they tell you area. They want the area. So you would have committed to memory this formula here, half base times height. Don't forget I told you that the height and base were perpendicular to each other. The base and the height were perpendicular to each other. All right, so you have area is half base times height. The only problem, and it's not even a problem, for you would have been to understand that this here and this here really unnecessary. So you have half, the base is 15 feet times the height, which is 8 feet. You get half of 8 is 4 times half of the 8 is 4 times the 15. You get 60. You get 60, so you circle 3. So it shouldn't take you a lot of time. The units would be feet squared. Area is always feet squared. One of the things that we always emphasize on this show, is mastery level understanding. You could have used the Pythagorean theorem to get this side, all right, and then found the area half base times height of these two sides. You could use the Pythagorean theorem with this leg and this leg to get this side, and then once you got this side, you half base times the height here. We don't have time to do mastery level for this particular show. All right, so let's look at another problem. Try to do as many problems as we can tonight. All right, so what we have here, look at number 11. Right now I'm on page 921 of that GED book. For people who are trying to keep up with us as they look at this book, what we have here is a circular pond. That tells you right now what shape you're working with. But the question is, are you going to need to do the perimeter of the circle, or are you going to need the area of the circle? Are you going to need the distance around the circle, or are you going to need the distance or the amount of space inside the circle? Well, you got to read the problem carefully. It says a circular pond has a circumference. That's the giveaway right there. Circumference, that's the distance around of 628 feet. So the formula for the circumference, you will have already committed that to memory. 2 pi r. They tell you that the circumference is 628 is equal to 2 pi r. And they say, what is the distance in feet from the center to the edge? From the center to the edge. What they're testing you on is, do you know what the center to the edge means? We talked about that earlier in the show, and we defined the distance from the center to the edge as the radius. So all you're doing is solving for the radius. You divide by 2 pi on both sides. You get the radius is equal to 628 divided by 2 pi. And I already did that. Before the show. And you get the 100, which would yield an answer of 1.